Hello everyone, welcome to today's webinar. Today we're going to go over the first section of the fractions unit. The fraction unit is the second unit in General Math 1, and this unit is the most challenging unit according to our data that students face some difficulty understanding the concepts to or of. So today we're going to start a series of webinars that will go over the unit of fractions. Today is the first session. Next week will be the second session, and the following week will be the last session. Before we start our webinar, I'd like to introduce myself. My name is Miriam. I'm here, the math instructor for Penn. I did join the team back in 2015. I'm certified to teach high school math in the state of Pennsylvania since 2010, and I just earned my master's degree in education last year. Today I'm going to go over some objectives here, and these are only the basics of fractions, the things that we need to know in order to be able to multiply, add, divide, and subtract. So before we are able to do those operations, we need to understand some basics about fractions. I want to remind everyone that is attending today and everyone who had registered to the webinar that you're able to get the recording after the conclusion of this webinar. You also are able to ask questions by typing your questions in the questions box. The raise your hand feature is not enabled. So before we get into the how to work with fractions, let's understand fractions. And we all have some background about fractions. So a fraction is a way to represent a part over a whole. So we usually use pizza or cake or a pie to demonstrate the idea of fractions. So I brought those three pizzas just to give you an idea on how can we write a fraction to represent a part of a whole. The first pizza, without counting any parts, it looks like it's a half a pizza. So I can do 1/2. And the second one is a half a pizza too. And the third one, as you see, is half. But I'm also able to rewrite the fraction using an equal fraction to a half. So if I look at this pizza, it originally had 8 pieces. So the total number of the parts would be the denominator of the fraction. That would be an 8. And if I want to represent how many pieces of that pizza is remaining on the tray, I'm going to count 1, 2, 3, 4, and that will be the numerator for the fraction. So 4/8 is the same way as saying half. These two fractions look so different, but in core, they have the same value. So I'm able to say that half equals to 4/8. The same thing with the second pizza. Originally had 12 pieces. So I'm able to write the denominator as the 12, the whole, the total number of pieces. And out of the 12, there are 1, 2, 3, 4, 5, 6 pieces remaining on the tray. So 6/12 is equivalent also to a half. And again, these three fractions are different, but they have the same value. They are equivalent fractions or equal fractions. And the same way for the third one, originally had 16 pieces. So I'm able to represent the remainder of the pieces as a fraction with a denominator of 16, and then count the remaining parts, 1, 2, 3, 4, 5, 6, 7, 8. So 8/16 is equal to a half. Now from this slide, we conclude that you are able to write half in so many different ways. And this is how we find the equal fractions to a given fraction. So if I want to do then, if I want to use math, instead of looking at the figures for the pizza, what do I do in terms of numbers and math that I'm able to go from a half to 4/8? Well, the idea of finding an equal fraction is to multiply the top and the bottom times the same number or the same factor. So to get from 2 to 8, I did multiply times 4. and I have to do the same thing on the top times 4. And that's how I got from 1 over 2 to 4 over 8. These two are equal, and they remain equal because I did use the same factor on top and bottom. So 1 times 4 is 4, 2 times 4 is 8. And the same thing, how did I go from half to 6 over 6 over 12? I did multiply times 6 and times 6. 1 times 6 on the top is 6, 2 times 6 is 12. In the same manner with the last fraction, I did use the same factor, which is in this case 8. And this is how we find equal fractions to a given fraction. How many equal fractions there are for a given fraction? There is infinite number of equal fractions. So if I want to use the same method with only fractions, no figures, nothing to demonstrate, how can I get an equal fraction to a given fraction? How do I do math, again, to find an equal fraction? So question number 1 is asking 10 over 15 is equivalent to which fraction so that the other fraction has a 60 in the denominator. So find an equal fraction to the given fraction 10 over 15 so that this equal fraction has a 60 in the denominator. The same way we have done with the pizza example. I want to find a factor. I'm able to multiply 15 times, so it give me the 60, the denominator given in the equal fraction. So 15 times what should give you 60? If you're not sure, you can pick up your calculator and divide 60 over 15 will give you what? That will give you the factor. The factor in this case is a 4. 15 times 4 is 60. And to keep the fraction equal, I need to do the same thing on the top. So 10 times 4 is 40. So 40 over 60 is the same as saying 10 over 15. Is 40 over 60 the only equal fraction to 10 over 15? And the answer is no. There is unlimited number of equal fractions to the given fraction, but the only fraction I decided to write here is 40 over 60 because they determined that the denominator must be 60. So in that case, there is one equal fraction to 10 over 15 that has a 60 in the denominator. If you have any questions, you can type your questions in the questions box. Number 2, the same thing. What over 108 equals to 4 over 9? In this case, 4 over 9 is the given fraction. The denominator in the equal fraction should be 108. What times 9 will give you 108? You can divide. 108 over 9 will give you the factor, and the factor in this case is 12. So since we did multiply 9 times 12, we have to do the same thing on the top, 12 times 4, and that will give you the numerator for the equal fraction 48. The same thing, 2 over 6 equals to what over 144? Again, 2 over 6 is the given fraction. 6 times what will give you 144? Not sure. Divide. Divide 144 divided by 6, and that will give you the factor that you're going to use to find the numerator for the equal fraction. 6 times 24 should equal to 144. Do the exact same thing on the top times 24. 24 times 2 is 48. So 48 over 144 is an equivalent fraction or is an equal fraction to 2 over 6. Any questions? Anything that was not clear on how to find an equal fraction to a given fraction? Okay, let's look at a self-check question. These questions are there just to give you an idea of how a question would look like, give you a chance to do the question yourself. These are not graded. I do not go back to the data and see who did get that question wrong or right. These are just given for you to self-assess yourself on that topic. If you get these questions wrong, it is a sign for you that you may want to watch the webinar again, and maybe you have to revisit the topic in your unit before you attempt the exam. But if you get them correct, it's a sign that you got that concept. So what happens with these questions is you have the question here. In a minute or so, I'm going to change my screen to give you the same question, but a chance to enter your answer. So the question again is the same thing that we have been doing since the beginning of the webinar. What is the equal fraction to 5/3 such that the equal fraction have an 18 in the denominator? Which one of these are an equal fraction to 5/3? You can have your time, write down the question, and think about a factor that you multiply 3 times and will give you 18, and do the same thing on the top for the 5, and what number you should put on the numerator. I'm going to give you some time and then change my screen. Remember, if you're not sure what factor you should use, you can divide. You can divide the second denominator 18 divided by the original denominator 3, and that should give you the factor. And if you use it correctly, you'll be able to find the correct answer from the ones given in this question. Okay, I'm going to change my screen. I'm going to give you the same question, but this time you're able to enter your answer. And here you go. Okay, a few seconds just to give everyone a chance to enter their answers. Okay, let's do the question together. So again, the question is asking 5/3 equals to what over 18? We figured out that 6 would be the factor because 3 times 6 will give us the denominator in the equal fraction. So multiply times 6 and multiplying times 6 on the top. 6 times 5 is 30. So B is the right answer. 30/18 is an equal fraction to 5/3. Any questions on this problem? Okay, let's then go to the next topic. How can we compare two fractions? You're given two fractions and you need to compare them. We have three cases that we're going to go through about comparing fractions. The simple case would be when you are comparing two fractions with the same denominator. Let's read the question and try to make sense of how can we compare the fractions. Would you rather having 1/10 of a cake or 3/10 of the same cake? Let's assume that you want to have the more portion, the larger portion. Which one is larger? Which one you're going to pick for yourself, the 1/10 or 3/10? Well, I mean, even if you do not know fractions, it's just a common sense to pick 3/10 because that in our mind means that we have two cakes the same size. We cut each of them to 10 equal pieces, and in your mind you will compare 1/10 or 3/10. So 3/10 would be the greater fraction. But the way you also want to think about it is if you have the denominators the same, compare the numerators. The one with the greater numerator is the greater fraction. So we can write 3/10 is greater than 1/10. Or I can state that a different way, saying that 1/10 is less than 3/10. And in this case, I'm going to pick the larger portion if I'd like to have more sweets. So that is simple. Let's look at another case, number 2, when you have to compare two fractions, but they do not have the same denominator. I cannot do, 9 greater than 5, then 9 over 14 is the greater or larger portion. We cannot do that. You may be right. Maybe the answer is going to be at the end that 9 over 14 is larger, but this is not the right method. It's not going to work on every two fractions that you have with different denominators. So what should we do? Would you rather having 9 over 14 of a pi or 5 over 7 of the same pi? Using just imagination, we cannot really tell which one is bigger. So the only way to do that is to change the two fractions to equal fractions with the same denominator. Now, I know that one has a 14 and the other one has a 7. I know that 14 is a multiple of 7. 7 times a number will give me a 14. So in my mind, I can change 5 over 7 to an equal fraction with a 14 in the denominator the same way we have been doing. So I'm going to do 5 over 7, and then I'm going to multiply that times 2 and times 2. And why did I pick 2? Because 7 times 2 will give me 14, and 14 is the same denominator as the other fraction. So that way I'm able again to compare the numerators and decide which one is larger or which one is smaller. 7 times 2 is 14, and 5 times 2 is 10. So this fraction is equivalent to 10 over 14. So the first fraction says 9 over 14. The second one is 10 over 14. Which one is larger? The 10 over 14, because our method says now if the two fractions have the same denominator, what they have, then compare the numerators. The one with the larger numerator would be the larger fraction. So that way we are able to say that 9 over 14 is less than 10 over 14, or just to go back to the original fractions, we can say 9 over 14 is less than 5 over 7. And if you want more pi, you will then pick the 5 over 7 option. If you want less, then you're going to go with the 9 over 14. Any questions? Okay, let's go back to the same topic, case number 3. We're still comparing fractions. This time, the fractions that you see on the screen, they have different denominators, but the same numerator. So in that case, we have another rule that we go by. Let's read the question. Would you rather having 4 over 6 of a pizza or 4 over 15 of the same pizza? Let's try to make sense of the fractions and see if that would help us decide which portion would be larger. If you have two pizzas the same size, you cut one into 6 pieces and the other one into 15 pieces. So the one was cut into 6 pieces will have bigger pieces, larger pieces, but the one that was cut into 15 pieces, each piece is tiny. Would you then rather to have 4 large pieces, 4 over 6, or 4 tiny pieces, 4 over 15? What do you think? Which fraction would allow for more portion? And the answer would be the 4 over 6, because you're going to get 4 large pieces. So what's the rule behind it? The rule behind it is when you have two fractions, have different denominators but the same numerator, the fraction with the smaller denominator will be the fraction of the larger value. So in that case, I'm able to right away say that 4 over 6 is greater than 4 over 15. So if you want more pizza, you're going to go with the option number 1. Less pizza, then you're going to go with option number 2. Any questions? Anything that was not clear about comparing fractions? Okay, let's move on then to the next slide. We're still going to compare fractions, but we're going to have these kind of problems. Number A, 5 over 16 is what to 17 over 32? We're supposed to use either the greater than, less than, or equal sign to make those statements true. So we're going to do the same thing. We are going to do the comparison. We're going to decide which case is that. We have two fractions for number A, two fractions. They have different denominators, different numerators. Then that is case number 2. Case number 2. What should we do to compare these two fractions and use one of those symbols? I'm going to look at the denominators, 32 and 16. With my knowledge of the multiplication table, I know that 32 is a multiple of 16. 16 times a number will give me 32. What is that number? 2 times 2 and times 2. Then I'm changing the first fraction to an equal fraction with a 32 in the denominator. So I'm able to use the case number 1 to compare only the numerators. So 5 times 2 is 10 over 32. I'm comparing that with the 17 over 32. Again, I did not change the second fraction because it already had the 32 in the denominator. In this case, I have two fractions. They have the same denominators. Compare the numerators. Then I'm able to write the right sign for the fractions. 10 is less than 17, then the first fraction is less than the second fraction. And I'm able then to say that 5 over 16 is less than 17 over 32. Question B, 6 over 11 and 6 over 21. This is case number 3, where we had the same numerators and different denominators. So that is case number 3. And if you remember the pizza example, these are 6 large pieces and these are 6 tiny pieces. So we compare the denominators. The one that has the smaller denominator is the fraction with the larger value. So in that case, we would put the sign greater than in between the fractions. Number C, 5 over 14 and 9 over 14. That is case number 1, straightforward. Compare the numerators since the denominators are the same. 5 over 14, 9 over 14, the 9 is greater. Then I can say, well, 5 over 14 is less than 9 over 14. Number D, 45 over 45 is what to a 1? We know that a part of a whole, if the part on the top the same as the whole, that means I'm gonna eat the whole pizza. If I cut my pizza to 6 pieces and I eat all 6 pieces, 6 over 6 is 1. So that would be equal to 1. Any questions? Okay, let's go to a self-check question on the same topic, comparing fractions. We have 6 over 25 is what to 16 over 75. You can write down the question. Take your time looking at which case is that question, case number 1, 2, or 3. If it's case number 2, which is a little bit harder than the other two cases, you want to compare the denominators and determine if you have to use a factor to change one of the fractions to an equal fraction. I'm going to leave you with that question for a few seconds here and then change my screen again to give you a chance to enter your answers. Okay, let me change the screen. We'll give you the same question and you'll be able to say your answer and enter it. Here you go. 6 over 25 is what? 216 over 75. Again, which factor you're able to use to change the 25 to 75. Okay, let's do the question together. Thank you for everyone who did enter their answers. Again, the purpose of those questions not to evaluate you now, it's just to give you a chance to participate in the webinar as like a classroom. We used to do in classrooms, and also ask questions and also self-assess yourself. Let's do the question together. So again, it's case number 2. The denominators are different, the numerators are different, then I'm going to think about 75 and 25. Well, I know that 75 is a multiple of 25. 25 times what will give you 75? If you're not sure, you can use a calculator. But really, if you think about the quarter with a dollar, you know that 3/4 will give you 75 cents. So you know that 3 times 25 will give you 75. Do the same thing on the top. That will give you 18 over 75. Compare that with the original fraction 16 over 75. Now compare the fractions, same denominators, compare the numerators. 18 is greater than the fraction itself is also greater. So the answer is A. Let's go to the next topic. If you're given two fractions and you were asked, are they equal or not equal? How would you know? There is a test that you're able to do to determine the equality or inequality of two given fractions. And we call the method cross multiplication. What you basically do is you cross multiply and find the product. 1 times 30 is 30. And cross multiply and you write down the product. 5 times 6 is also 30. The rule says if you do the two cross multiplications and the two products are equal, then the fractions themselves are equal as well. So I am able to conclude that the two fractions are equal, again, because the cross products are equal. The same thing with number 2. 4 over 12 and 21 over 60, are they equal or no? We'll do the cross multiplication test. 21 times 12, and that will give you 252. And do the other cross multiplication. 4 times 6 is 240. The products in this case are not equal. Then that means that the fractions themselves are not equal. They are unequal. Third one, two fractions, are they equal or no? Cross multiply. 6 times 36 will give you 216. 25 times 9 will give you 225. Again, the products are not equal, then the fractions themselves are not equal, unequal or not equal. That's it. Very simple. Any questions on this method? Okay, let's do a self-check question on that one topic. The fractions 17 over 34 and 41 over 82 are what fractions? Are what? What do you think? Are they equal, improper, unequal, or like? I would just ignore the number D for now because I want to go over like and unlike fractions. So D is not the answer. But what about the other three? Just to be fair and give you the ones that we have gone through so far. Improper fractions. Most of you know what's an improper fraction. Are they equal or unequal? What do you think? I'm going to leave that screen up, do the cross multiplication test, and see which word is good to be put there so the statement is true. When you cross multiply, I would recommend that you use a calculator again because we are not learning how to manually multiply two whole numbers. We are learning now how to check if two fractions are equal. So I think that when you use a calculator in this topic, you eliminate distraction because, again, you're trying to learn how to find out if two fractions are equal, not to practice manually multiplying two numbers, but it's up to you. Are these fractions equal or not equal? What do you think? Let me put the question up and you're able to select your answers. Let's do the question together. So again, are they equal or no? The first thing that comes to my mind is to do the cross multiplication test. So what I'm going to do is multiply 41 times 34, and that is 1,394. And do the same thing with the 17 times 82, and that will give you the product 1,394 as well. The products are equal, then the fractions themselves are also equal. So these two fractions are equal. Any questions on this example? Okay, let's move on to another topic, which are equal and like fractions. And that's why I just eliminated the choice number D on the previous question, because I wanted to go over the concept before you're able to apply that. So equal fractions are the ones that we have been going through since the beginning of the webinar. Examples like 1 over 3 and 5 over 15. If you cross multiply, you will find the product equals the product, or if you think about it, 3 times 5 will give you 15, and also 1 times 5 will give you 5. So 1 over 3 and 5 over 15 is an example of equal fractions. They do not look like anything like each other's, but in the core value, they are the same. Now, what about like fractions? Like fractions is so simple. If the two fractions have the same denominator, we call them like fractions. They look alike. So 1 over 3, for example, and 5 over 3, these are like fractions. Are they equal? No. The only reason that we call these two fractions equal is because this has a 3 and this has a 3 in the denominators. That's it. Students sometimes mix up equal with like fractions. So remember, equal fractions, they look different, but they have the same core value. But the like fractions, all it matters is the numbers on the bottom, the numbers on the denominators. If they're the same, I don't care about the value. If they're the same, then they are like. If they are not the same, like for example, 1 over 5 and 6 over 10, they are unlike. Even if you find out that two fractions are equal, like this example, these are equal fractions, but we call them unlike fractions just because that one has a 3 and this one has a 15. So this set of fractions, we can call it equal and unlike. That's it. And these ones are not equal and they are like fractions. Okay. Let's go to a self-check. Very simple. 51 over 1,000 and 62 over 1,000 are what fractions? Are they unlike? Are they equal? Are they like fractions or improper fractions? What do you think? Okay, I'm going to put the question on, and please select your answers. 51 over 1,000 and 62 over 1,000 are what? Are they unlike, equal, like, or improper? Okay, I'm going to wait for everyone to select their answers. Just a few seconds, and then we can do the question together. Okay, let's do the question together. Well, since they have the same denominator, the only right answer from the ones given in this question is like C. Well, of course, they are not equal because the denominators are the same. 62 is greater than 51, so one fraction is greater than the other one, so that means they are not equal. So equal is wrong. Unlike, well, that is wrong because both fractions have the same denominator. Improper, the numerator is smaller than the denominator in both cases. So actually the two fractions are proper fractions. So this is incorrect. The like is the right answer. So I'm able to put this word here, and that would make my statement correct. Next, another question on the same topic. 79 over 65 and 34 over 25 are what fractions? Unlike, equal, like, or proper? What do you think? Here's the question. Are they unlike? Look at the denominators. Are they unequal? I'm sorry, are they equal? You can do the cross multiplication if you'd like. Are they like or proper? And try not to get confused between equal and like. Like or unlike deals with the denominators only, if they're equal or no. But equal or unequal fractions, it depends on the core values of the fraction overall, not only the denominator. Okay, let's then do the question together. So since the two fractions have different denominators, I know they are unlike, but what about the other options? Equal? They are not equal. Do the multiplication, the cross multiplication, you will find that they are not equal. Like, that is not correct because the denominators are not equal. Proper? That is not right. The numerator is greater than the denominator in each case. So actually both fractions are improper. The only right answer is A, unlike. One more question on that topic. 3 over 15 and 1 over 5 are what fractions? Are they unlike and unequal? Are they unlike and equal? Are they like and equal or like an unequal? What do you think? You can eliminate some answers so you can focus on maybe 2 or 1 or 3. What do you think? You can just think about the fractions. Are they unlike or like? And then depending on your finding, you can then choose, are they equal or unequal? I'm going to put up the question. You can select your answers. Okay, let's do the question together. Well, first of all, both fractions have different denominators. So the last two options are incorrect. The fractions are not like. Now, the question will become, are they equal or no? Cross multiply 1 times 15 will give you 15. 3 times 5 will give you also 15. The products are equal, then the fractions also are equal. So those fractions are unlike but equal. So B is the right answer. Any questions on this topic? Equal versus like fractions. Okay, let's move on to the next topic. How to simplify a fraction. Why do we need even to simplify a fraction? Well, simplifying a fraction is putting the fraction in the simplest form. So for example, if I tell you that I have eaten 5/15 pieces of a cake, would you be able to understand how big or how much of the cake I did eat? Or if I told you 1/3 of the cake, I did eat 1/3, a third of the cake, which one you can visualize in your mind? Of course, the 1/3, the third of a cake, you can visualize that more than saying, well, 5/15 is really how much, like how big from how much from the cake did you eat? So the same thing. 5/15 is a form of 1/3. 1/3 is a simplest form of saying 5/15. But again, third will reveal the core value of the fraction more than 5/15. The same thing with those questions that we have on the screen. We're going to try to simplify those fractions so we're able to visualize the core value of each fraction. How do we simplify a fraction? We simplify a fraction by dividing over the common factor between the top and the bottom numbers. So 12 has some factors. 18 has some bunch of factors. The common ones are the ones we can divide over, and that will give us the simplest form. Okay, let's make that more clear. What are the set factors of 12? Well, I like to use the tree. I'm going to show you how to do the tree on one example, and then I'm going to do the other ones with just simple math, but you still can do the tree method after the webinar just to see how did we simplify the other two fractions. So I'm going to divide that screen to 2. That's not a perfect line. I tried. So I'm going to list the factors of 12. I'm going to make the tree. 12 is 3 times 4 and also 6 times 2, but I'm going to start with 3 times 4. Any two factors of 12 can be the first level of your tree. 3 is a prime number. 3 is what times what? 3 times 1. So that's it for the 3. I cannot factor 3 anymore. So I'm going to leave the 3. Look at the 4. 4 is what times what? It's 2 times 2. Am I able to factor 2 and 2 even more? And the answer is no. Then the factors of 12 are 3, 2, and 2. What about 18, the denominator? Remember, we want the common factors between 12 and 18. So we're listing the factors of 12 and 18 and see which ones are common, are shared between the two. 18 is 3 times 6. Well, 3, that's it for it. And then 6 is 3 times 2. Now we have the list of factors of 18, 3, 3, and 2, 12, 3, and 2, and 2. What are the common factors? The factors that you see at the end leaves of that tree that are shared between the 18 and 12. This is the manual way. This is the step-by-step way. I'm going to show you that method, and it's up to you if you want to use it or no. I'm going to circle the ones that are common. 3 is common. So 3 is a factor, common factor, and also one of the 2's are common. So 3 and 2 and 3 and 2 multiply. 3 times 2 is 6. 6 is the common factor between 12 and 18. Divide over 6 and divide over 6. And that will give you the simplest form right away. 12 over 6 will give you a 2. 18 over 6 will give you 3. So the core value of 12 over 18 is 2/3. If I tell you I ate 2/3 of the pizza or 12 over 18 of the pizza, which one you're able to understand more? The simplest form, 2/3. So that is the extended way of doing so. You're able to do the tree method. I would recommend it if you're still not good in simplifying fractions. By practice, though, you're able to do the second method I'm going to show you now. So I'm going to write down the original fraction from question number 1 and try it a different way. I'm going to look at the number on the top and the bottom. They are even number. I know that even numbers has a 2 as a common factor because they are even. They are divisible by a 2. So I'm going to divide over 2 and divide over 2. This method is not going to give me the simplest form of the fraction from the first step. That may take me a lot of steps to do. But again, it's another way. 12 over 2 will give you what? 6, and 18 over 2 will give you 9. Well, 6 over 9, still, there are some common factors I'm able to eliminate. 6 and 3. Think about the multiplication table. 6 and 9, I'm sorry. So 3 is a common factor. Divide over 3. Divide over 3. And that is the second step. When you divide over 3, 6 over 3 will give you what? 6 over 3 will give you the 2. And 9 over 3 will give you the 3. So the same answer as the first method. So both methods will give you the right answer. One will give you the right answer right away. The other one may require some steps to arrive to the simplest form. Well, it may look like so long, and sometimes you can call it boring, but with practice, you will be able to simplify fractions more fast. Okay, let's do the second fraction using the second method. 48 and 54, they're even numbers. They happen to be even numbers. They don't have to be even numbers, but in our example, they are even. So I'm going to use this feature of my numbers and divide over 2, again, because they are even numbers, and see what's next. 48 divided by 2 will give you 24 on the top, and then 54 over 2 will give you 27 on the bottom. Okay, 24 and 27. There is a common factor I know from my knowledge of the multiplication table. I know it's 3. I know it's 3. Divide over 3 and divide over 3. 24 over 3 is what? Will give you 8. And 27 over 3 will give you 9. And this is the simplest form of 48 over 54. If you do the tree method, you will arrive to the same fraction from one step, using only one step. Questions on this topic before I go ahead on the third example? You can type in your questions on the questions box. Okay, let's do the third method, 27 and 90. 27 is not an even number. I cannot use 2 as a factor to divide the bottom and the top of the fraction. I need to think about something else. I have 27 and 90. I know that 9 times 3 will give me 27, and I also know that 9 times 10 will give me 90. So the common factor between 27 and 90 would be a 9. Divide over 9 and divide over 9 equals 2. 27 over 9 is 3. 90 over 9 is 10. You can do it another way. You can say, well, I cannot figure out the 9. Let's do the 3. Well, I know that over 3 and over 3, that will give me 27 over 3 will give me a 9. 90 over 3 will give me a 30. But there is another common factor I need to eliminate over another 3 and over another 3, and that will give you the same answer. That's it. Any question? Let's do a practice question and see how we're going to do with that questions. The simplest form for 24 over 32 is, you can use the tree method, list all the factors for both numbers, and circle the common factors, multiply them together, and then in one step, you're able to find the simplest form of that fraction, or you can look at the top and the bottom and realize something there, and that would be the start for simplifying the fraction. Write down the problem and see which fraction from the 4 given here is the simplest form of the given fraction. Okay, I'm going to change my screen to give you the question itself and also a chance to enter your answers. Which fraction is the simplest form? And I hope that no one is using a calculator, because with a calculator, you are able to tell which fraction without doing the work that we have been doing on the previous slide. Remember, we want the simplest form, not just an equal fraction to 24 over 32. We want the end, the most reduced fraction to 24 over 32. Which one is that? Okay, let's do the question together. Again, we have 24 over 32. I'm going to do the second method. 24 over 32, they happen to be even numbers. I'm going to use that feature, divide over 2 and divide over 2. 24 over 2 is 12. 32 over 2 is 16. Okay, again, even numbers. Divide over 2 and divide over 2 equals 2. 12 over 2 is 6. 16 over 2 is 8. Again, even numbers. There's more to eliminate. Divide over 2 and divide over 2 equals 2. 3 over 4. So 3 over 4 is the simplest form, the most reduced form for the given fraction. Any questions on this example? Let's go to the next topic, which is proper versus improper fraction. That may be basic information that you already know in your head, but let's go just over it quickly. We have two kinds of fractions, improper and proper. A proper fraction is when the numerator, the top number, is less than the bottom number. Examples, 3 over 7 is a proper fraction. 5 over 20 is a proper fraction. Again, why? Because the top number is less than the bottom number. And also another way to think about it is the value of that fraction when the top number is less than the bottom number, the fraction is always less than 1. It's equivalent to a less than 1. It's not a 1.5, for example. It's not a 1 and 3 over 4. It's less than 1. So in this case, we call it a proper fraction, fraction to the definition, because a fraction is a part of something. So when it's less than 1, it meets the right, proper, accurate definition of a fraction. So that's why we call it a proper fraction. An improper fraction, well, it's a fraction, but it's more than 1. So it has some kind of a fraction now concept, but it's really over the value of 1, or 1 or over the value of 1, I should say. Example, 5 over 2 is a fraction, but really if you look at 5 over 2, if you have 2 pizzas and you cut each one into 2 pieces because the denominator is 2, you eat, or you have 3 pizzas actually, and you cut each one into 2 parts, then you eat 1, 2, 3, 4, 5, you have a 1 left there. So it is more than a 1 pizza. It's 2 and some part of a pizza. So in that case, the numerator is greater than the denominator. That is an improper fraction. 21 over 3, improper fraction. What about 10 over 10? In this case, nothing is greater or less than the other number. Well, we call it again improper because that is a whole number. That's a 1. It's not really a fraction. Like it has the form of a fraction, but the value is 1. So again, we call it an improper fraction. Let's then see how can we change an improper fraction like the one we have on the screen, 15 over 4, to a mixed number. A mixed number is a mix of a whole number and a fraction, like 1 and 1 over 2. That is a mixed number. In example, 1 and 1 over 2, that is a mixed number, a mix of a fraction and a whole number. How can we represent the improper fraction into the form of a mixed number. The way we're going to do that is to think how many times the denominator goes into the numerator. Another way, if it's too hard for us to think about it, like mentally do the math, you can do the calculator. You can use a calculator and you can divide 15 divided by 4. And that will give you a number and some decimals. Ignore the decimals. If you divide 15 over 4 in the calculator will give you 3 and some decimals. So 3 is the whole number part of the mixed number. What about the rest of the mixed number, the fraction part? 4 will stay the same. It was the denominator. It will stay the denominator in our mixed number. What about the top part? The top part, we're going to figure it out by doing so. 3 times 4 is 12. Subtract the original numerator from the product. 15 minus the product, which is 12. So 15 minus 12 is what? 3. So instead of saying 15 over 4, it's hard to imagine 15 parts over 4 parts. It's easier to say, well, 3 and 3/4. I know now what I'm talking about. I can visualize 3 cakes and 3/4 of a cake. Again, the same with number 2. 41 over 9, that's an improper fraction. It will be written as a mixed number. How can I do that? Either think about how many times 9 goes into 41 or use a calculator, divide. 41 divided by 9 will give you what? It will give you 4 and some decimals. Ignore the decimals and write the 4. That is the whole number part. The denominator is the same, 9. It was 9, make it a 9. The numerator, multiply 4 times 9 will give you 36. Subtract 41 minus 36 will give you the 5 as the difference, which is the numerator for the fraction part of the mixed number. That's it. Any questions on this method? Okay, let's do a question on how to change an improper fraction to a mixed number. 135 divided by or over 11. What would that be in the mixed number form? Some answers provided are not right. So you can tell right away that they are not correct. So do the division, find the whole number part, write the denominator, and then find the remainder or the difference between the original numerator and the product. What would be the mixed number value of this improper fraction? And here is the question. Okay, let's do the question together. Again, how many times 11 goes into 135? Maybe it's hard to do it mentally, so use the calculator, divide. 135 divided by 11 will give you 12 and some decimals. Ignore the 12. So from that one step, before I even figure out the fraction part, I can eliminate all the answers except B. But let's do the whole problem. So 12. The fraction part would be 11 on the denominator because it's going to have to say the same. And then multiply 12 times 11 will give you 132. Subtract 135 minus 132 will give you the remainder 3 on the top. And that is answer B. That's it. Questions on this problem? Okay, let's move on to the other way around. What if You have a mixed number and you're trying to represent this mixed number into the improper fraction form. What should we do? We're going to do the opposite. Multiply 30 times 7, multiply the whole number times the denominator. So 30 times 7 is what? 210. And then add the product to the numerator. 210 plus 5 will give you 215. That will give you the new numerator. The denominator simply stays the same. That's it. So the improper fraction form of this mixed number is 215 over 7. Again, multiply. 10 times 13 is 130 plus 10 is 140. That is only the numerator. The denominator stays the same. 140 over 13 is the same as saying 10 and 10 over 13. That's it. Questions? Okay, let's do an example together. So a mixed number 11 and 5 over 9 is what improper fraction is the one that represents this mixed number. 11 and 5 over 9. In the previous topic, when we did change the improper fraction to mixed number, we divided and subtracted. In this topic, we do the other way around and we do the opposite operations. We multiply and add instead of dividing and subtracting. Which improper fraction is the right representation to the mixed number given? And here is the question. Okay, let's do the question together. Again, we are changing a mixed number to an improper fraction, multiply and add. 11 times 9 is 99. 99 plus 5 will give you 104 on the top and 9 will stay on the bottom. So B is the right improper fraction for this mixed number. Any questions on today's webinar? Any questions on any of the topics that we went through during this webinar? You can type in your questions if you just joined it. Okay, well, my math part of the webinar has ended. I just want to give you some tips how to study for the webinar. We did, of course, go through these topics, finding an equal fraction, comparing fractions, determining the equality or inequality of fractions, like and unlike fractions, simplifying or reducing a fraction, and we just did the changing improper to mixed numbers or the other way around. How to study for the exam. Well, this webinar is not enough for you to do good in the exam or understand fractions just for you, because, I mean, you will have to use fractions sometime in your life. I'm sure about that. I've used them before. So to study and learn the topic, you need to read the unit, do the lessons, read them, take notes. There are practice questions provided within each lesson. They may be called practice questions, self-checks, or discover more questions. These are not required of you to pass the course. They are not graded, but they're provided for a reason. They're provided to give you practice for the exam. So use the opportunity that someone sat there and put some problems for you so you're able to practice before you take the exam. The answer keys for those questions are provided as well. So use that. If you do the questions, you're not sure if you're right or no, look at the answer key. If most of your answers are correct, then mostly you are ready for the exam. If most of them are incorrect, please do not attempt the exam. You also can watch that webinar again. You can send your questions on the webinar or anything on the study unit that you are not sure about. How can you call for help? You can call the school 9 to 6 Eastern Time weekdays. You can schedule an appointment with an instructor or teacher assistant using that link. You can text message your brief questions. You also can email and chat. From your student portal, you're able to go to resources or help center, I should say, help and support center or help center. And from there, you're able to email or use the chat feature that we just added to the accounts. And you're able to send your questions, chat about brief questions that you have in your mind about that course. Thank you for everyone who did attend and who registers for this webinar. There is a small survey, only 3 questions. I'd like you to take the survey and give me a feedback on how I did throughout this webinar, whether it's a constructive criticism or like a praise or things that you liked in the webinar, or maybe things that you wanted to get changed in future webinars. Thank you so much, and I'm here just for a few seconds. If you have any questions in your mind, you can share them on the questions box, and I'll be happy to answer them for you. Okay, well, I thank everyone once again. Good luck in the exam.